There are excess interstitial fluids that are transported through our blood, as well as various infections that can attack our body system. But have you ever considered how these escaped fluids from the cardiovascular system are transported back to the blood, and how our body defends itself against infection and diseases that we may encounter? Well, this presentation would be all about the lymphatic system. So what are you holding out for? Come fly with us as we take off to the lymphatic system.
Good afternoon, passengers. This is the pre-boarding announcement for Flight MCON-01 to Lymphatic System City. We are now inviting those passengers with small children and any passengers requiring special assistance to begin boarding at this time. Please have your boarding pass and identification ready. Regular boarding will begin in approximately 5 minutes. Thank you. This is the final boarding call for passenger Janet Austin, booked on Flight MCON-01 to Lymphatic City. Please proceed to K3 immediately. The final checks are being completed, and the captain will order for the doors of the aircraft to close in approximately 3 minutes' time. I repeat, this is the final boarding call for Janet Austin. Thank you.
Hi, I am Janet. Is this the flight for Lymphatic City?
Yes, madam. The drainage system that removes excess fluid, which is the lymph, that is carried by lymphatic vessels is known as the lymphatic system CT. This lymph is transported from the body tissues and returns back to the bloodstream. This CT is also essential for disease resistance and body defense. Furthermore, the lymphatic CT is also in connection with the circulatory system, which will be more discussed to one of our flight attendants, Ms. Kea Havilinar, in the airplane. Please proceed to your respective plane. Thank you.
The lymphatic system is a subsystem of both the circulatory and immune system. The circulatory system functions to bring oxygen and nutrients into the body tissues as well as remove waste, which happens within the capillaries. Blood plasma that contains nutrients move out of the arterial ends of the capillaries, while the tissue fluid that contains waste is absorbed back into the venous ends of the capillary. However, 15% of the fluid is left in the tissues and could cause swelling if accumulated. This is where the lymphatic system comes in. It drains the excess fluid and returns it to the circulatory system. As lymph moves through the vessels, it passes through lymph nodes, and the white blood cells made in the lymph nodes filter out germs and destroy them. The clean lymph and white blood cells move throughout the body and help fight infection.
Ladies and gentlemen, welcome on board Flight MCON-01. We are currently first in line for takeoff. Please fasten your seatbelts and secure any luggage underneath your seat or in the overhead compartments at this time. We also request that your seats and table trays be upright for takeoff. Furthermore, in front of your seat is a screen on which you can watch various movies as well as information about our destination, Lymphatic City. Thank you for flying with NURS Airlines. Have a safe flight.
Good day, everyone. I am AJ, one of your flight attendants. Now, I am going to discuss how lymphatic system functions. First is we have fluid balance. It is a net fluid loss from capillaries into interstitial fluid. Lymphatic system returns excess fluid from tissues to the circulation. Second is protection. Lymph passes through lymph nodes containing many immune cells. Lymphatic system protects against pathogens and often destroys traveling cancerous cells. And last is we have fat absorption. Dietary fat from the digestive system is absorbed into lymphatic capillaries. Always remember that our lymphatic system is part of our immune system that protects our body from illness-causing invaders, to maintain our body fluid levels, and absorb digestive tract fats and remove cellular waste. It also blocks diseases or infections that can affect our lymphatic system's function. And that's it. I hope you understand and learned something. Have a safe flight.
Ladies and gentlemen, we are now 30,000 feet high, and right now we are seeing the view of the different towns around the lymphatic city, which are the lymph town, lymphatic vessels, ST lymphoid organs, epithelial lymphoid system, and bone marrow town.
Welcome to Lymph Town, one of the safest towns around. Our town lymph is simply a tissue fluid that enters the lymph capillaries. We commonly refer to lymph as the fluid that flows throughout the lymphatic system, which helps maintain fluid balance and remove bacteria from tissues. Now, our little town lymph is composed of many different things. First and foremost, the lymph is a clear watery fluid that is similarly composed to plasma. The lymph from the small intestine called chyle is a bit different. It has a milky white appearance because of the large droplets of fat that it absorbs from the intestine. Apart from that, there are plasma proteins that leak out from the capillary beds. The lymph is the one responsible for transporting them back into the bloodstream. And finally, to keep the town clean and safe, the lymph also sweeps away large particles like bacteria and debris, which gets filtered out and destroyed by the lymph nodes. All in all, you'll most likely see lymphocytes, which is a type of white blood cells that destroy bacteria, macromolecules of proteins, fat droplets, and particulate matter when talking about lymph. And finally, the most exciting part of our town, the drainage system. Because of the fluid and debris that flows through it, the lymphatic system is commonly referred to as the drainage system of course type. Every day, approximately 30 liters of fluid flows from the artery ends of the capillaries into the intercellular space, and 27 liters of fluid, mainly macromolecules, is absorbed back into the venous ends of the capillaries as a result. The lymphatic capillaries then absorb the remaining 3 liters. Now, it is important to know that if the lymphatic system does not remove these 3 liters, it could accumulate in the tissues and cause swelling, also known as lymphoedema. That is all for our little town lymph. We hope you enjoyed your stay and safe travels as you go to your next destination.
Good day, passengers! Have you seen any lymphatic capillaries? Well, lymphatic capillaries are tiny vessels found in the tissues of most organs in your body. They transport and filter lymphatic fluid or lymph from your body cells and tissues. They help to keep consistent blood pressure and volume and prevent fluid buildup. As lymph capillaries collect interstitial fluid from tissues, the pressure in the lymph capillaries grows. This increasing pressure moves the lymph fluid forward towards the heart. Everywhere in your body, your lymphatic capillaries collect lymph and move it into larger lymphatic vessels. These lymph capillaries consist of cells that line the capillary walls, which are the endothelial, which is supported by the basement membrane. In addition, it also contains mini valves that let lymph flow into the capillaries but not out of them. And lastly, they contain elastic fibers and attach the endothelial cells to fibroblast cells in connective tissue. Here is the figure where you can see the structure of lymph capillaries. Lymph capillaries are found between cells and in the tissues of every organ in your body, except in your avascular tissues, meaning body tissues without blood vessels, which include cartilage, the cornea, lens of your eye, and the epithelial layer of your skin. And lastly, the central nervous system, including your brain and spinal cord. Remember that lymphatic capillaries are similar to blood capillaries, however, they are large in diameter and have closed ends. Unlike blood capillaries, fluid can flow into lymph capillaries but can't flow out through the cell walls. It can only move forward. Now, friends, come and continue to join us in this adventure.
Hello and welcome to Lymphatic Vessel. You can call me Aline and I'll be the one to lead you to Lymphatic Vessel. Our busy-town lymphatic vessels are made up of lymph capillaries, which are small vessels that connect to form lymphatic vessel, as is shown in the illustration. This lymphatic vessel has a thin wall and beaded appearance in anatomy, and it's a path where the lymph flow in lymphatic vessel is unidirectional. The lymphatic vessel passes through a series of lymph nodes before the lymph is drained into the venous system, or that refers to your network of veins and the way your veins connect with other blood vessels and organs through your body. What to expect from clinical correlation? Lymphangitis and lymphatic filariasis are two major examples of clinical correlation that will be discussed later on in the next reporter. Like a wall of veins, the wall of lymphatic duct has the same three layers. An example, tunica adventitia, tunica media, and tunica intima. And as we all know, the lumen of lymph duct contains valves that are more numerous and closely packed than veins. In addition, the lumen of vessel is proximal to the valve and expanded into sinus. While the valves are closely paced, the lymph vessel, when filled for lymph, have a beaded appearance. Next are the two major lymphatics of body, including the right lymphatic duct and the thoracic duct. The main function of thoracic duct is to transport lymph duct into the circulatory system. A duct is a circumscribed channel leading from an organ that has 45 cm in length and drain lymph from the lower extremities, abdomen, left thoracic region, left side of the head and neck, and upper limb. As you can see in the illustration, it's the apple green shaded part. While on the other hand, the right lymphatic duct drains into the right subclavian vein. It drains the lymph from right thoracic region, right side of the neck, and head, lastly at the right upper limb.
Greetings! I will introduce you to the part of lymphatic vessels found, which is the superficial and deep lymphatic vessels. They are the lymphatic vessels that are divided into two types based on their location. The superficial lymphatic vessels are found in the subcutaneous layer of the skin, where they collect the lymph from the superficial structures or parts of the body. They follow the drainage of a network of veins and lastly, drain into the deep lymphatic vessels. While the deep lymphatic vessels carry lymph from the internal organs, the arteries work together with us by pressing on the walls and supporting the flow of the lymph. Both of the lymphatic vessels go through the lymph nodes that monitor the content of the lymph. We will also pass to the lymph drainage. The illustration that you are seeing right now will be our guide for our topic. After crossing the lymph nodes, the lymphatic vessels will combine to form bigger vessels known as the lymphatic trunks, and each drains the lymph from a major portion of the body. First, the jugular trunks drain lymph from the head and neck. The subclavian trunks is responsible from the upper limbs, superficial thoracic wall, and mammary glands. Then the bronchomediastinal trunks drain lymph from the thoracic organs and the deep thoracic wall, while intestinal trunks drain lymph from abdominal organs such as the intestines, stomach, pancreas, spleen, and liver. Lastly, lumbar trunks drain lymph from the lower limbs, pelvic and abdominal walls, pelvic organs, ovaries or testes, kidneys, and adrenal glands.
Now we have reached the lymphoid organs. So the lymphoid organs can be classified into two groups. The primary lymphoid organs, which are involved in lymphocyte proliferation, and secondary lymphoid organs, which are involved in the activation of lymphocytes and triggering immune response. Despite their difference in functions, lymphoid organs share a similar structure, which consists of a specialized reticular connective tissue and the body's immune soldiers, such as lymphocytes, plasma cells, and macrophages. First up are the lymph nodes, called kulani in Tagalog. These are organs along with the course of lymphatic vessels where the lymph passes through as it travels towards large lymphatic duct. They vary in sizes. Some are as small as pinhead, and the largest are about the size of the almonds, up to 1 inch and smaller in shapes of bean to oval. There are about 600 to 700 lymph nodes all over the body, and they cluster along lymphatic vessels, commonly in inguinal, axillary, and cervical regions. A little trivia, lymph nodes are pink in living bodies and brownish in cadavers. Delving deeper, we will now be discussing the structure and later on the functions of lymph nodes.
Each node consists of a convex and concave or indented surface. Connected on the convex side are the afferent lymphatic vessels, or simply afferent lymphatics, while on the indented region, or called the hilum, are the artery, veins, and efferent lymphatics. Surrounding each lymph nodes are fibrous capsule in which trabeculae or connective tissue strands extend inwards, dividing the nodes into several partitions. Basically, nodes are consisted of two portions, the cortex and medulla. Cortex is further subdivided into outer and inner cortex, also called paracortex. Outer layer is called B-cell layer, as it is mostly made up of B lymphocytes that are arranged in follicles which have dark staining centers called germinal centers. In addition, it may also contain other cells such as macrophages and follicular dendritic cells. Meanwhile, paracortex is also called T-cell layer, as it is made up mostly of T lymphocytes with macrophages and dendritic cells as well. Going deeper, we will reach the innermost layer, the medulla, which have the presence of plasma cells. Another fundamental part of lymph nodes are the sinuses, which are spaces where lymph flows through. There are 3 types of lymph node sinuses based on location, namely subcapsular sinuses that are found just below the capsule, trabecular or cortical sinuses, which are branches of subcapsular sinuses into further paracortex, and lastly, medullar sinuses located in the medulla layer. The flow of lymph starts as it enters through afferent lymphatics, moving towards subcapsular sinuses, continuing in trabecular or cortical sinuses, into medullary, and finally draining at the efferent lymphatics. Note that there are valves present in every vessel. Their role is to make the flow only one way, which is towards the heart. Ultimately, if you may notice, the afferent outnumbers the efferent vessels. This makes the flow of lymph slow, allowing time for lymphocytes and macrophages to perform their protective functions.
Speaking of functions, let's now move forward to the functions of lymph nodes. So essentially, lymph nodes' functions are filtration as it filters lymph, immunity response as it produces lymphocytes in the germinal centers and at the same time produces antibodies by the plasma cells, and it also serves as portal of entry for lymphocytes into lymphatic channels. In the clinical settings, lymph nodes are one of the means to identify infection and early sign of a disease, and large lymph nodes are often an early diagnostic sign of a disease or infection, which is why doctors always check the cervical region for this during checkups. The swelling means that the lymph nodes are fighting the infections. However, if the swelling persists, it may be an indication of a cancerous occurrence, as lymph nodes can be secondary cancer sites when they already contain cancer cells.
Let's move on to the next lymphoid organ, the spleen. It is the largest lymphoid organ and just about the size of a fist. It is located posterior to the stomach and just beneath the diaphragm in the left side of the abdominal cavity. The structure of the spleen includes the dense capsule, which surrounds the organ, trabeculae, connective tissues that provide internal support for the spleen and carry the blood vessels into it, and contains 2 main types of tissue. The red pulp, which is made of sinusoid capillaries and is where most of the filtration occurs, and the white pulp, which is made of masses of lymphocytes that monitor the blood for pathogens and are capable of initiating an immune response. Here are some of the functions of the spleen. It filters and cleanses the blood from antigens and microorganisms such as bacteria, viruses, and other debris. It also evokes an immunological response against the antigens circulating in the blood. It produces B and T lymphocytes, which are the 2 main types of lymphocytes and are responsible for the adaptive immune response of an organism. It also removes old and abnormal red blood cells and returns some of their breakdown products to the liver. The spleen also removes bacteria by phagocytosis because the red pulp contains macrophages. And it stores blood and forms blood cells during fetal life. because in the fetus, the spleen is an important hematopoietic or blood cell forming site. But as a rule, the adult spleen produces only lymphocytes. Other functions of the spleen includes storing platelets and acting as a blood reservoir like the liver. Next lymphoid organ is the thymus. It lies in the upper part of the mediastinum behind the sternum and extends upward into the root of the neck. It is devoid or lacks lymph capillaries and lymphoid nodules. It weighs about 10 to 15 grams at birth and 20 to 30 grams at puberty. Then it regresses and is converted into fibropathy tissue. Some of its functions include being the site of production of T lymphocytes or T cells, which help your immune system fight disease and infection. It receives immunologically incompetent stem cells from the bone marrow, and these cells divide and mature into T lymphocytes. T lymphocytes are important for both cellular and humoral immunological responses, which will be further discussed later. The thymus also secretes hormones known as thymosin, which supports the activity of T lymphocytes throughout the body, or function in the programming of T lymphocytes so they can carry out their protective roles in the body. And that is for the lymphoid organs down.
Welcome passengers, we are now at the epithelial lymphoid system down. When you hear epithelial lymphoid system, remember that it is comprised of mucosa-associated lymphoid tissue or MALT. The MALT is the aggregates or sum of non-encapsulated lymphatic tissue which is not enclosed. It is found in and beneath the mucous membranes lining the digestive, respiratory, urinary, and reproductive tracts. MALT is generally divided into two types, the bronchus-associated lymphoid tissue or BALT in the respiratory system and the gut-associated lymphoid tissue or GUT. The BALT is the build-up of lymphoid cells that actively engage in airway immune responses. It is composed of T and B lymphocytes but also contains plasma cells, dendritic cells, and macrophages. And the GALT is the important antigen sampling and adaptive immune inductive locations within the intestinal wall. It is one of the largest immune organs in the body, and lastly, it consists of Peyer's patches, the vermiform appendix, and the multiple isolated lymphoid follicles, which are distributed along the length of the intestine. The collection or accumulation of mucosa-associated lymphoid tissue are the following: pharyngeal tonsil, tubal tonsil, palatine tonsil, lingual tonsil, Peyer's patches, and the abdominal tonsil. Most of them are found within the pharynx and also fights infection.
On to our next town. It is not the red sparrow and definitely not the black sparrow, but welcome to the bone marrow town. It consists the red bone marrow that provides the body with 60 to 70% of lymphocytes, which is a white blood cell composed of B cells and T cells. These cells produces antibodies within the lymphatic system that prevents and destroys viruses, bacteria, and even cancer cells. These primary lymphoid organs generate lymphocytes from immature hematopoietic progenitor cells, such as lymphoblasts, that are immature cells which can develop into all types of blood cells, including white blood cells, red blood cells, and platelets. Oh no, passengers! Have you seen someone experiencing problems with their lymphatic system? Well, there are different clinical anatomies occurring or that can occur in body's lymphatic system. First, the lymphedema that can be caused by cancer treatments that remove or damage your lymph nodes. Any type of problem that blocks the drainage of lymph fluid can cause lymphedema. Second, lymphangitis occurs when bacteria or viruses enter the lymphatic channels. They may enter through a cut or wound, or they may grow from an existing infection. Third, an infection caused by a parasite that causes the lymphatic system not to function correctly is known as the elephantiasis or lymphatic filariasis. Fourth, cancer can spread through the bloodstream or lymphatic system. What happens is that cancer uses the bloodstream or lymphatic system to travel to different parts of the body to form and spread tumors. Fifth, lymphadenitis is a case when lymph nodes become infected, caused by an infection through bacteria, viruses within one or more lymph nodes. Rarely, lymph nodes can enlarge due to cancer. And lastly, did you know that your spleen is a normally fist-sized organ that's located on the upper left side of your abdomen under your left rib cage? However, it is called splenomegaly when it is enlarged caused by different infections, liver, and blood disorders.
Good afternoon, passengers. This is your captain speaking. First, I'd like to welcome everyone on Nurse Airlines Flight MCON-01. We are currently cruising at an altitude of 33,000 feet at an airspeed of 400 miles per hour. The time is 10 a.m. The weather looks good, and with the tailwind on our side, we are expecting to land in Lymphatic approximately 10 minutes ahead of schedule. If the weather cooperates, we should get a great view of the city as we descend. The cabin crew will be coming around in about 20 minutes to offer you a light snack and beverage. The in-flight movie will begin shortly after that. I'll talk to you again before we reach our destination. While our flight attendants, Ms. Havilanar and Ms. Lumio, offers you snacks and beverages, they will also discuss some of the cultures within the Lymphatic regarding body defenses. Until then, sit back, relax, and enjoy the rest of the flight. Good afternoon, passengers. We hope that the complimentary snacks and beverages are to your liking. As you continue to enjoy your food, we will be explaining to you the cultures within the Lymphatic regarding body defenses. The Lymphatic is very particular about their security. It is one of the most guarded places you'll visit. One of those defenses is the innate body defense. The innate body defenses, innate meaning non-specific, are the mechanical barriers that cover our body surfaces against invading pathogens. One of these defenses is the surface membrane barrier, which is the first line of defense against disease-causing microorganisms. They are the first to act against invading pathogens. It's composed of the intact skin, or epidermis, which acts by physically blocking most microorganisms that swarms the skin using the keratinized epidermis. There are also skin secretions produced by the acid mantle, which makes the skin surface acidic to stop bacterial growth. It also secretes sebum, which contains bacteria-killing chemicals. Keratin is also present within the intact skin. Its role is to give resistance against acids, alkalis, and bacterial enzymes. Apart from the intact skin, we also have the mucous membranes, which provide a mechanical barrier that keeps pathogens out. These membranes not only act as physical barriers, but also create a number of protective secretions. One of them are mucus. First, we have the mucus traps. The sticky mucus traps many microorganisms that enter digestive and respiratory passageways. The nasal hairs ensure that bacteria and other airborne particles in the nasal passageway are filtered and trapped. Cilia pushes debris-laden mucus out of the lower respiratory passages. The gastric juice, which contains hydrochloric acid and protein-digesting enzymes, both kill pathogens. The acid mantle of the vagina inhibits bacterial growth, and the sebum, which contains chemicals, are also toxic to bacteria. The vaginal secretions of adult females are also very acidic. And finally, lacrimal secretion, or tears, and saliva. Tears cleanses the eyes, while saliva cleanses the oral cavity, because they both contain lysozyme, an enzyme that destroys bacteria, which also provides lubrication.
The other body defense is the adaptive body defenses. Now, adaptive body defenses is also known as the specific defense mechanism, which is the body's third line of defense. It is a functional system that recognizes foreign molecules called antigens and acts to inactivate or destroy them. It is a process that produces activated lymphocytes and antibodies specific to the invading pathogen. Normally, it protects us from a wide variety of pathogens as well as from abnormal body cells. It is a powerful defense which reacts to a specific invader, which requires a special environment for them to develop in response to that specific antigen. There are two main types of lymphocytes. The B lymphocytes or B cells and the T lymphocytes or T cells. These cells are the white blood cells of the immune system that are responsible for the adaptive immune response of an organism. Both the cells are made in the bone marrow, and B cells mature in the bone marrow, while T cells travel to the thymus and mature there. These lymphocytes use lymphatic vessels to migrate from tissues to lymph nodes for them to carry their function. B lymphocytes or B cells are responsible for antibody-mediated immunity, which involves the activation of B cells and secretions of antibodies when in contact with a pathogen. B cells produce antibodies that are used to attack invading bacteria, viruses, and toxins, and also can target specific extracellular antigens. Meanwhile, T lymphocytes or T cells are responsible for cell-mediated immunity that involve the destruction of infected cells by cytotoxic T cells or the destruction of intracellular pathogens by macrophages. It can recognize and eliminate specific virus-infected or tumor cells. Unlike B cells, T cells do not make antibodies. And that is for the lymphatics body defenses. Now that we have discussed some of the cultures within the lymphatic regarding body defenses, we hope we have provided you with enough knowledge in a good time.
Ladies and gentlemen, we are aware that you have a layover flight departing to Fago City. Our ground staff will work with you to confirm you on the next flight to your destination, Lymphatic City. The local time is 10:30 a.m. For your safety and the safety of those around you, please remain seated with your seatbelt fastened and keep the aisle clear until we are parked at the gate. Thank you for your patience.
Good day, everyone. Welcome to Fago City, one of the best city on town. Now, I am going to explain what is phagocytes and its main function. Phagocytes are the immune cells that plays a critical role in both early and late stages of immune response. The main role of phagocytes in the lymphatic system is to circulate and migrate tissues to ingest and destroy both microbes and cellular debris. In addition, pathogens that make it through the mechanical barriers are confronted first by the phagocytes in every body organ. A phagocyte such as macrophages or neutrophils, it engulfs a foreign particles with the process of phagocytosis. We must remember that phagocytes eliminates pathogenic bacteria, fungi, and malignant cells. And it also contributes to adaptive immunity by presenting antigens to lymphocytes.
Good morning, passengers. This is your captain speaking. We have arrived on your layover flight, Fago City. Flight attendants, prepare doors for arrival and cross-check. We will be using stairs for deplaning today. Please watch your step. Thank you for choosing Nurse Airlines. Be safe, and we hope that you enjoyed your flight today. Kindly wait for your next flight's announcement to your final destination inside the airport. Thank you very much. And again, this is Kea, your captain for today.
Good morning, ladies and gentlemen. On behalf of NURS Airlines, it is my pleasure to welcome you again on Flight MCON-01 with service to Fago City and continuing service to Lymphatic City. As a reminder, smoking is not permitted in any area of the aircraft, including the lavatories. On behalf of the captain and your entire crew, it is our pleasure to have you aboard. Enjoy your flight.
Welcome to humoral antibody-mediated immune response, one of the famous city on town. Our humoral immunity produces antigen-specific antibodies and is primarily driven by B cells or what we call the B lymphocytes with specific receptors bound to a specific antigen. The binding event synthesizes or activates the lymphocytes to switch on and undergo clonal selection. In clonal selection, it is the process where lymphocytes begin to grow and multiply rapidly to form an army of cells exactly like itself and bearing the same antigen-specific receptor. To continue, a large number of clone formation is the primary humoral response to that antigen. Humoral antibody-mediated have two different immune response which are the primary and secondary immune response. In clonal selection, it is the process where lymphocytes begin to grow and multiply rapidly to form an army of cells exactly like itself and bearing the same antigen-specific receptor. To continue, a large number of clone formation is the primary humoral response to that antigen. Humoral antibody-mediated have two different immune response, which are the primary and secondary immune response. In primary immune response, the level of antibody in the blood peaks about 10 days after the response begins and then slowly declines. While in the secondary immune response, it is a later immune response that is produced faster, more prolonged, and more effective than the event of the primary response because all the preparation for this attack have been already made. So here is the figure on how primary and secondary responses to an antigen. As you can see in the primary response, the level of antibodies of the blood gradually rises and then rapidly declines, while in the secondary response, it is both more rapid, more intense, and the antibody level remains high for much longer time. Moving on, we have the active and passive immunity as part of the humoral antibody. In active immunity, it is when your B cells encounter the antigen and produces antibodies against them. You are exhibiting naturally acquired during bacterial and viral infections, in which we may develop the signs and symptoms of the diseases and suffer a little. While in the artificially acquired, it is when we receive vaccines. Take note, most of the vaccines contains pathogens that are dead or inactivated, living but extremely weakened. We can receive two benefits from vaccine. First is they spare us most of the signs and symptoms and also discomfort of the diseases that would otherwise occur during primary response. The second is they weakened antigens are still able to stimulate antibody production and promote immunological memory, or also called the booster shots. Vaccines have virtually wiped out smallpox and are currently available against microorganisms that causes pneumonia, polio, tetanus, diphtheria, whooping cough, measles, and many other diseases. That's why being vaccinated and receiving vaccines is very important. Next, we have the passive immunity. It occurs when antibodies are obtained from the serum of immune human or animal donor. Your B cells are not challenged by the antigen. Immunological does not occur in the temporary protection provided by the donated antibodies, which end with the naturally degrade in the body. It naturally acquired from a mother to her fetus or in the breast milk, and it artificially acquired from immune serum or gamma globulin. Take note that gamma globulin is commonly administered after exposure to hepatitis. Other immune sera are used to treat poisonous snake bites or what we call the anti-venom, botulism, rabies, and anti-tetano or antitoxin, because these diseases will kill a person before active immunity can be established. The donated antibody provide immediate protection, but their effect is short-lived and can last up to 2 to 3 weeks. And last and the most exciting part is the monoclonal antibody. It's used for cancer treatment, diagnosis for pregnancy, and treatment after exposure to hepatitis or rabies. In addition, monoclonal antibodies used to provide passive immunity, antibodies that are prepared commercially for use in research, in clinical testing, diagnostic purposes, and in treating certain cancers. And that is all for our humoral antibody-mediated immune response. I am AJ, your flight attendant. I am happy to serve and see you on board.
Ladies and gentlemen, the use of approved portable electronic devices is now permitted. But during the cruising altitude of our flight, the use of portable electronic devices will not be authorized. For your continued safety, please keep your seatbelt fastened at all times, even if the captain turns off the fastened seatbelt. Remember that there is also a safety instruction behind your seats with information about antibodies as well. Thank you.
A little more patience, and you are finally to arrive at Lymphatic System City. But before that, let's first learn about antibodies. So antibodies, or also referred to as immunoglobulins, are soluble proteins that are secreted by activated B cells or by their plasma cell offspring in response to an antigen. And it also constitutes the gamma globulin of the blood protein. It has 5 classifications, each have slightly different roles and functions due to slight difference in structure, but even though they vary, they all have similar basic anatomy, which looks like this. As you can see, it consists of 2 identical heavy chains and 2 identical light chains, which are only about half as long as heavy chains. Chains are linked together by disulfide bonds, producing a Y-shaped molecule as a whole. It also has a variable or the V regions that are responsible for the formation of antigen binding sites. Each is uniquely shaped for a specific antigen. And it also consists of a constant or the C regions that function for the identification of antibody class, how they will carry each immune roles, as well as determining cell types or chemicals which they will bind with. Moving on, as I have said, it has 5 classes abbreviated into MADGE or MADGE acronym. If you'll notice, immunoglobulin D, G, and E have the singular basic Y shape and that they are called monomers, appearing to be similar in structure, but they have different locations and functions. Immunoglobulin D is found attached to B cells and is important in the activation of B cells. Immunoglobulin G is the most abundant antibody in plasma as it is the main antibody in primary and secondary responses. It fixes complements and provides fetus passive immunity through crossing placenta. Meanwhile, immunoglobulin E is produced through secretions of plasma cells in the skin, GI, and respiratory tracts as well as in the tonsils. It is important in some allergic responses. Next to monomers is immunoglobulin A, which occurs as both a monomer and a dimer or 2-linked monomers. Its monomers are in plasma, while its dimers are in secretions such as tears, saliva, intestinal juices, and milk. It protects those related mucosal surfaces against pathogens. Lastly, immunoglobulin M, called as pentamer due to its 5-linked monomer structure, is found attached to B cells or free in plasma. It also fixes complements and serves as antigen receptor and agglutinating agent. As for functions, there are 5 ways antibodies inactivate antigens. First is complement fixation, in which complement or our body's chief antibody ammunition fighting against cell antigens are being fixed or activated, which then binds with antibody, finally causing target cells to burst or what we call cellular lysis. Second is neutralization, which occurs when antibodies bind to specific sites of bacteria or viruses, causing them injury and preventing binding to body cells. Third is agglutination, which results in clumping of foreign cells into large complexes, which eventually becomes non-mobile and easier to destroy. Fourth is precipitation, which makes antigen-antibody complexes so large it settles out of solution, and this process involves soluble antigens that become much more easily captured and engulfed by phagocytes as they are immobilized or precipitated. Lastly, opsonization is the process that uses opsonins like immunoglobulin M, for instance, to mark antigens for phagocytosis.
Passengers, we have begun our descent into Lymphatic City, here in the CMIA or Cellular Mediated Immune Airport. Please turn off all portable electronic devices and stow them until we have arrived at the gate. In preparation for landing in the city, be certain your seat back is straight up and your seatbelt is fastened. Please secure your carry-on items, stow your tray table, and pass any remaining service items and unwanted reading materials to the flight attendants. Thank you.
Hello and welcome to Lymphatic City. Today I'm going to talk about the cellular mediated immune response, but first we need to familiarize ourselves with the following. Immunity, the ability of the body to resist any infection. Immune system, defense mechanism developed by our body to protect itself from foreign invasion. WBC, or white blood cells, are the soldier of the body. CMI, cellular mediated immune response, produced by specific cell of our bodies which is different from the immune provided by antibodies. and also called the third line of defense mechanism. Who can we recognize and meet among the T cell family? T helper cell helps other cell to stimulate immunity when the pathogen attack by sending signal. T killer cell, are also called the cytotoxic T cell, kill the infected cell or sometimes pathogen directly without harming the uninfected cell. T suppressor cell suppress the action of T cell when the infected has been removed. T memory cell create a significantly large and faster attack than the first response. And to give an analogy, nagkaroon ka ng sakit. May matitira sa mga cells na antigen to produce antibodies. That antibodies, kapag bumalik yung same host or pathogen na nagbibigay ng sakit, the cell will active the immune response by help the T cell family. Finally, that's it. We already know how CMI work. We are now near to our final destination, friends. Aren't you excited?
Passengers, ladies and gentlemen, welcome to your final destination, the Lymphatic System City. Local time is 12 p.m. and the temperature is 25 degrees. For your safety and comfort, please remain seated with your seatbelt fastened until the captain turns off the fasten seatbelt sign. This will indicate that we have parked at the gate and that it is safe for you to move. At this time, cellular phones may only be used once the fasten seatbelt sign has been turned off. Please check around your seat for any personal belongings you may have brought on board with you. And please use caution when opening the overhead bins, as heavy articles may have shifted around during the flight. If you require deplaning assistance, please remain in your seat until all passengers have deplaned. One of our crew members will then be pleased to assist you. On behalf of Nurse Airlines and the entire crew, I'd like to thank you for joining us on this trip, and we are looking forward to seeing you on board again in the near future. Have a nice stay in the Lymphatic System City.